Good morning. It's February 25th, and this is your daily brief in science. Here's everything you need to know. Recent research suggests that Mars may have once hosted sandy beaches and conditions conducive to microbial life, pointing to the existence of a significant northern ocean. This new understanding implies that Mars had evolving shorelines, which supports the hypothesis of a dynamic environment akin to Earth's coastal areas. Geologist Benjamin Cardenas from Penn State University stated that the beach hypothesis provides the best explanation for the geological structures observed on Mars. Utilizing ground-penetrating radar, the Zhurong rover has uncovered sand-like materials at depths ranging from 10 to 35 meters, indicating the presence of ancient beaches. The analysis of these materials revealed underground sedimentary deposits similar to Earth's beaches, suggesting a dynamic interface of air and water consistent with coastal environments. It is believed that warm, wet conditions capable of supporting life may have persisted for tens of millions of years, facilitating shoreline shifts and the potential development of organisms. The study's co-author, Cardenas, emphasized that the discovery of ancient beaches and river deltas enhances our understanding of Mars' geological history. The existence of an oceanic environment raises questions about the potential for life on Mars, similar to the conditions under which early life forms developed on Earth. Scientists estimate that this ocean may have existed approximately 3.5 to 4 billion years ago, during a time when Mars had a thicker atmosphere and a warmer climate. Hai Liu from Guangzhou University underscored the importance of Zhurong's ground radar in making these discoveries, particularly given the significant changes to the Martian surface over billions of years. The Zhurong rover, which landed in 2021, has played a crucial role in exploring subsurface geology and searching for signs of water on Mars, ruling out other geological origins for these deposits, such as river flows or volcanic activity. Researchers at the University of Southern California have unveiled a groundbreaking AI model that measures the speed of brain aging. This development offers critical insights into cognitive decline and dementia prevention. The innovative model employs a three-dimensional convolutional neural network, or 3D-CNN, to analyze over 3,000 MRI scans, tracking changes in the brain over time and assessing the pace of aging. The tool utilizes MRI scans to non-invasively monitor brain changes, revealing a link between faster brain aging and a higher risk of cognitive impairment. Senior author Andre Irimia expressed optimism that this model could identify individuals at risk for accelerated brain aging before cognitive impairment symptoms manifest, which could enhance preventive strategies for Alzheimer's treatment. The research aims to provide prognostic measures for Alzheimer's risk, aiding in the development of tailored prevention drugs and strategies. Notably, the study also highlighted sex-based differences in brain aging rates, which may account for the varying risks of neurodegenerative disorders between men and women. Traditional methods of measuring biological age, such as blood samples, are ineffective for assessing brain aging due to the blood-brain barrier, making a non-invasive approach like MR1 necessary. This framework could serve as an early biomarker for neurocognitive decline, helping to differentiate healthy aging from disease trajectories. Published in the Proceedings of the National Academy of Sciences, the study emphasizes the critical distinction between biological brain age and chronological age, which is based solely on birth date. Previous models estimated brain aging from single MR1 scans, but lacked the capability to track the timing or rate of aging over time. The model demonstrates a strong correlation between the speed of brain aging and changes in cognitive function in both healthy adults and Alzheimer's patients. Researchers at Purdue University have unveiled a new computational tool named nufold, which is set to transform the modeling of 3D RNA structures. This development is particularly significant as it aims to bridge the gap between the various known RNA types and the limited structural data currently available. Led by Daisuke Kihara, the study published in Nature Communications outlines how nufold was developed over 3 years using advanced machine learning techniques to predict RNA's full atomic structure directly from its sequence. Yuki Kagaya, the main developer of nufold, highlighted its capability to accurately represent RNA's flexibility and base pair interactions. In benchmark tests, nufold outperformed traditional methods, marking a notable advancement in the field. The implications of this tool are profound, as it holds the potential to enhance our understanding of RNA mechanisms and facilitate drug development for RNA-related diseases. The research received backing from influential organizations such as the National Institutes of Health and the National Science Foundation, indicating its significance within the scientific community. The nufold team is composed of students and postdocs from both computer science and biology disciplines, reflecting a collaborative effort at Purdue University. To ensure accessibility, the nufold code and a Google Colab notebook have been made publicly available, allowing researchers and interested individuals to access RNA structural models easily. Kihara has drawn parallels between nufold and AlphaFold, a Nobel Prize-winning method for predicting protein structures, emphasizing its importance in advancing RNA research. Overall, nufold represents a significant leap forward in RNA research, promising to deepen our understanding of RNA structures and their implications in medicine. A recent study published in the Journal of Immunology has revealed concerning insights about the impact of sleep deprivation on our immune system. Researchers assessed the sleep patterns and immune cell profiles of 237 healthy adults with varying body mass indexes. The study found that just one night of inadequate sleep can alter immune cell profiles, making them resemble those of obese individuals, which increases the risk of inflammation. Specifically, significantly elevated levels of non-classical monocytes, essential for immune response, were observed in participants with obesity. This elevation correlated with poorer sleep quality and higher markers of inflammation. The findings highlighted that obese individuals typically experience worse sleep quality and exhibit higher levels of chronic low-grade inflammation compared to their lean counterparts. Interestingly, during the study, 5 lean individuals also underwent a sleep deprivation segment. Their monocyte profiles changed in a manner similar to those of obese individuals, reinforcing the connection between sleep and inflammation. These chronic disruptions in sleep may lead to long-term inflammatory diseases, including obesity, diabetes, and cardiovascular conditions. Dr. Fatima Al-Rashed, the lead researcher, emphasized the public health challenges posed by modern technology and lifestyle changes that disrupt sleep patterns. The long-term goal of this research is to inform public health policies that prioritize sleep as a strategy to mitigate the burden of inflammatory diseases. Future research will investigate the mechanisms linking sleep deprivation to immune changes and explore potential interventions, such as structured sleep therapies, to reverse these effects. A recent study from Northwestern University has uncovered a surprising benefit of brewing tea. It can effectively remove heavy metals, such as lead and cadmium, from water. This research, supported by the U.S. Department of Energy, is aimed at informing public health strategies regarding the risks associated with heavy metal exposure through drinking water. The study examined a range of tea types, including traditional options like black, green, oolong, and white teas, as well as herbal varieties such as chamomile and rooibos. Both loose-leaf and bagged teas were tested, revealing that cellulose tea bags emerged as the most effective at absorbing heavy metals. In contrast, cotton and nylon bags absorbed minimal contaminants and may even release microplastics into the water. Finely ground black tea leaves were identified as particularly effective due to their high surface area, enhancing their ability to absorb these toxic metals. The research also demonstrated that longer steeping times significantly improve tea's contaminant removal capabilities, with 3 to 5 minutes being optimal for a typical cup. Notably, steeping tea for extended periods, such as overnight for iced tea, can recover nearly all of the heavy metals present in the water. Lead author Benjamin Schindel suggests that increased tea consumption might correlate with lower incidences of diseases linked to heavy metal exposure. The findings, set to be published on February 25, 2025, highlight the potential for tea consumption to contribute to reduced heavy metal exposure on a global scale. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.